Welcome to video number 2 for the factoring review of our first week. On our worksheet, the second set of problems said to factor the common factor out of each expression. I will grant that it was not explicit and it did not say the greatest common factor from each expression, but that's a technicality. When we do these kinds of things, we want to make sure we're doing them the correct way, the same way rather, every time. So let's take a look at common factors. This particular person did not have an issue with common factors. Looks like this person was able to get out the greatest common factor, except on number 10, where he or she tried to pull out the r squared, but there's no r squared here. So you can only pull out an r squared if it's the smallest degree of the variable. Right now, the smallest degree of the variable would be r to the 0 power, or just basically your constant term. And so in that case, there's only the 6 that can be divided out. But where this person had their issues here was that all they did was show me what the greatest common factor was. They did not give me the rest of the expression. When I divide out that 3x to the 5th power, what does the expression become? Let's take a look at a second one here. Factor completely. Here we go. This person did take out the greatest common factor. Looks like they got it correct for all of them, but when they wrote this answer over here, they basically dissociated it. So this 3x to the 5th power needs to be in front of that negative 7 plus 16x plus 7x to the 3rd power. Otherwise, I have no way of multiplying this number to become 21 x to the 5th power. So you want to make sure you put them together. We've got another one here where it looks like they took out the greatest numeric factor, although that one could have been a little bit bigger. But we didn't take out the variable. Please remember that the variable is part of the term. So when I have n to the 7th power, n to the 5th power, and n to the 4th power, I can factor out the smallest degree of them, and then all of them should have some variable of n left over, even if it were n to the 0 power. This one did seem to pull out the variable with the numeric value, but we didn't take the lowest degree of the variable, so we didn't take enough of the variable out. So let's take a look at what an answer could look like. So here we are. This person realized that 3x to the 5th power can divide out from negative 21x to the 5th, positive 30x to the 6th, and positive 21x to the 8th. And so when they did that, they took that negative, sorry, it looks like this person factored out a negative 3x to the 5th. So that brings up two issues. One, make sure that you are getting all of the greatest common factor out, which in this case would be 3 from the numeric values and x to the 5th from the variable values. But if you do factor out a negative number, which is wholly appropriate, then that changes the signs. So this negative 21x to the 5th, just when we factor out the negative 3x to the 5th, all that remains is 7, because 7 times negative 3 gives me the negative 21. X to the 5th times 1, or x to the 0 power, will give me the x to the 5th. So notice that they changed all the signs, and that was done correctly because what was factored out was a negative 3x to the 5th power. This one didn't factor out a negative, but did take out the greatest common factor by factoring out 10 from all the numeric values and n to the 4th from all of the variable values. So n to the 7th divided by n to the 4th is n to the 3rd. N to the 5th divided by n to the 4th is just n. And n to the 4th, take out the n to the 4th, and you're just left with your number there. So that's the second video. The next video might be a little bit longer. Please bear with us. There are lots of different mistakes that were made, but hopefully this will help you do some studying.